We have started with a series of problems related to application of vectors. Let us see the first problem, which speaks about the average acceleration. The question is, a particle is moving eastwards with a velocity of 5 meters per second. In 10 seconds, the velocity changes to 5 meters per second northwards. The average acceleration is. So first, let us mark the northward direction, the east, west, and south. So if you just mark this, north, south, this is west, and this is east. And here the unit vector in the direction of east is I cap. The unit vector in the direction of west, the negative x-axis is minus I cap. The unit vector in the direction of north is j cap. And the unit vector in the direction of minus south is minus j cap. Positive x, positive y, and negative y. This problem can be solved in two methods using parallelogram law, triangle law, and the vector approach, the mathematical method where we will be using making use of this I cap and j cap that I'll take up in the next illustration. Let me solve this problem particularly using the parallelogram law method. So a particle is moving eastward. So the initial velocity is towards east. So this is the initial velocity, which is towards east, and that is 5 meters per second. In 10 seconds, the velocity changes to 5 meters per second towards north. North is this upwards. So this is the final velocity, and that is equal to 5 meters per second, the average acceleration. Now we know acceleration formula is nothing but change in velocity by time. What is acceleration formula? Change in velocity divided by time. Now keep in mind that acceleration is a vector quantity, because here the direction changes. You have to be very careful. So acceleration, we can write it as change in velocity is nothing but delta v divided by time. And delta v, we have to write it as v final minus v initial divided by time, isn't it? V final minus v initial divided by time. Now, how do we subtract two vectors? So we know subtraction can be simply written as extension of addition. V final vector plus negative of v initial vector divided by time. Now, how do you subtract these two? How do you add up now v final and negative of v initial? So what we will do is v final is kept as it is. V final is kept as it is. We have to take negative of v initial. How do you take negative of v initial? Negative of a vector is nothing but a vector which has same magnitude as the original vector, but the direction is opposite. So v initial is to the right. Negative of v initial will be towards left. The magnitude will be the same. Still, it will be 5 only. Still the magnitude is going to be 5. The magnitude of minus v initial is 5. The magnitude of v final is also 5. Now what you have to do with these two, we have to add them. We have to add them. And how do you add? We can add them using parallelogram law or triangle law. Since I have made the tails of v final and negative v initial to coincide, I'll make use of parallelogram law. So complete the parallelogram. Draw parallel side for v initial, that is minus v initial, and for v final you draw parallel side and complete the parallelogram. The diagonal is going to represent the resultant. This is nothing but the addition of v final plus the negative of v initial vector. Did you all understand? So I have just written acceleration is change in velocity, which is v final minus v initial, minus I wrote it as plus of minus, and then I have to add the two. Before adding, I need to take the negative of v initial. V initial is to the right, negative of v initial will be to the left, and add them using parallelogram law. And what is the magnitude of that? According to parallelogram law, I'll just write here v final plus negative of v initial. Anyways, we are adding, isn't it? So what is the addition magnitude? Root of v initial square, which is 5 square plus 5 square, root of p square plus q square plus 2pq cos theta, 2 into 5 into cos of the angle between the two vectors. The angle between the two vectors, v final and v initial, or minus of initial, is 90 degree, and cos of 90 degree is going to be 0. So this whole thing becomes 0. So root of 5 square plus 5 square will become 5 root 2. And then if I substitute here, magnitude of acceleration is v final plus minus of initial magnitude is 5 root 2 divided by time. Time is nothing but how much? Time is nothing but 10 seconds. So 5 ones are 5 twos are. Root 2 by 2 will become 1 by root 2. 1 by root 2 meters per second square. This is the magnitude of the acceleration. And as you can see, the direction is clearly, this was towards north, isn't it? V final was towards north, and minus of V initial was towards west. Minus of V initial was towards west, and the resultant V final plus negative of V initial vector is lying somewhere between north and west. So 1 by root 2 meters per second square towards northwest. So that matches with option number C. Let us take up the next illustration here. A particle is moving eastward with a speed of 6 meters per second. So initial speed. So the particle was initially moving towards east. As we know that east is I cap, north is j cap, south is minus j cap, west is minus I cap, the unit vectors in that direction. So initially the particle is moving towards east. As you can see, the particle is moving towards east, towards right. So initial velocity is simply, I'll solve this problem using the I cap and j cap method rather than applying parallelogram law. So initial speed is 6 I cap. And what about the final speed? As you can see, the final speed, it is neither along x-axis nor along y-axis. The vector is inclined. Whenever we know that whenever a vector is inclined, we have to resolve. What we have to do? We have to resolve. So how do you resolve 6? So this is 6 meters per second, final velocity, and inclined at an angle 60 degrees. So we can have two components, one along the positive x-axis and one along the positive y-axis. So how much is the x component? 6 cos 60 degree. So that is going to be cos 60 is nothing but half. So this is 3. And the vertical component is 6 sine 60 degree. And sine 60 degrees is root 3 by 2. So 2 3s are 6. So finally the y component is, this is the x component of the final velocity and this is the y component of the final velocity. So basically, how do you write the final velocity in vector form? Here applying the vector method will be more easier than applying the triangle or the parallelogram law. So final velocity, it is having an x component 3 along the positive x-axis. As you can see, it is towards the right. So the x component is 3 I cap. We know a vector is written as a magnitude and direction. Vector is going to have two things. One is the magnitude and direction. Magnitude is 3 and direction is I cap. And the y component, what is the y component? 3 root 3. 3 root 3 and the direction is what? Positive y-axis, that is j cap. This is positive x-axis I cap and this is positive y-axis j cap. So 3 I cap plus the y component is 3 root 3 magnitude and the direction is j cap. This is the final velocity in the vector form. I have just resolved a vector and I'm writing it in the component form. And the question is again the same. We need to find the magnitude of the average acceleration. So acceleration formula, it is a vector quantity. It is delta v by t, change in velocity by time. Change in velocity, we can write it as v final minus v initial divided by t. V final, what is the value of v final? 3 I cap plus 3 root 3 j cap is a v final minus v initial is 6 I cap divided by time. Time is nothing but it's given that after 6 seconds, the particle is found to be moving with the same speed, but making an angle 60 degree. So a time interval or the time elapsed is 6 seconds. So 3 I cap minus 6 I cap. We can add or subtract the like terms. So that is going to be 3 minus 6 is minus 3 I cap plus 3 root 3 j cap divided by 6. So I can take out 3 common. Before taking the magnitude, you take out the common terms so that it will be easier to take the magnitude. 3 if I take common, I'll be left out with 3 ones are 3 and then 3 has come out. So root 3 j cap divided by 6, 3 ones are and then 3 twos are. This is the acceleration in vector form. This implies a magnitude. So we know how to take the magnitude of a vector. So square root of x component square plus y component square plus the z component square. Half magnitude will be half only into, now you take the magnitude of this. How do you take the magnitude of this part? So that is equal to square root of the I component. I component is minus 1 square plus the j component. J component is a root 3 square. So this will cancel out. 3 plus 1 is going to be 4. Root of 4 is nothing but 2. 2 by 2 is going to be 1 meters per second square. So we saw two problems. One problem we saw using the parallelogram law method or the triangle law method. And the second method was the vector method. The first problem also could have been solved by the vector method. You can follow the same procedure. You will get the same answer.